Alright, welcome. Today we're going to be going through the June 2021 Pure Mathematics paper. Alright, if you just recently did the Pure Maths paper, you can just use this as a way to check how you have done at the exam. We're going to have lots of fun, so let's get straight into it. Alright, so question 1, I've said two complex numbers are given by z1 is equal to the square root of 5 over 3 plus the square root of 5i, comma, z2 is equal to 2 minus 2i, and we're supposed to prove, we need to prove that z1 over z2, we need to prove that z1 over z2 is the square root of 5 over 6 e to the 7 pi over 12 times I. Now there are two ways we can do this question. There are two ways we can do it. Alright, let's look at method 1. So method 1. So for method 1, we just start by rationalizing z1 divided by z2 will be equal to this right here, the square root of 5 over 3 plus, now look at this, it's a root 5, I can rewrite root 5 as the root of 15 over 3 times I, because 5 is 15 over 3. Why did I do that? I do that so this right here, it makes it easier for me when I'm going to rationalize, which we shall see, divided by 2 minus 2i. So now, of course, we multiply by the conjugate, and the conjugate is 2 plus 2i. So multiply by 2 plus 2i. When we do that now, what we're going to get is, we're multiplying, 2 times this is 2 times the root of 5 over 3. 2 times this plus 2 root, alright, maybe I won't have enough space. Let me go here. So 2 times each of them, so that's 2 root 5 over 3 plus 2 times this is 2 root 15 over 3i. 2i times this is plus 2i root 5 over 3 plus 2i times this is 2i, I times I make it I squared times the root of 15 over 3 all over, now the difference of 2 squared, 2 minus 2i times 2 plus 2i, this is the difference of 2 squared, that is now 2 squared minus 2i all squared. But what do we need to remember? I squared is equal to negative 1. So I have to remember that I squared is negative 1. Now since I squared is negative 1, we know that this is going to become negative 1 times 2 squared is 4, so the denominator is 8. So simplifying, this is telling us that, look what we're going to do now. The real, no I squared is minus 1, so this is also real. So what we end up with is 2 root 5 over 3. This is minus, I squared is minus 1, so that's 2 root 15 over 3. Bracket that part because that is the real part. Then now the imaginary part, which is with the I, that is now plus in bracket. Put in bracket, this is now 2 root 15 over 3 plus 2 root 5 over 3. multiplied by I all over 8. So that is what Z1 over Z2 work out to be. This is Z1 over Z2. Now, once you get to this step, I hope nobody did it this way, but just to do it the normal way. Once you get to this step, you notice everything have a 2. Since everything have a 2, we can divide the numerator and the denominator by 2. If we divide the numerator and the denominator by 2, if we divide numerator and denominator by 2, then I'm just going to skip that step. The 2 cancel, the 2 cancel, the 2 cancel, the 2 cancel. We end up get Z1 over Z2 is actually 5 root 3. So root 5 over 3 minus, this is root 15 over 3. Here, so now is divide out the 2, that's plus root 15 over 3 plus root 5 over 3 over 4. All I did was divide through by 2. Once you divide through by 2, now, remember, if we're trying to put it in this form, so we're trying to go from the regular form, the standard form of a complex number, to put it into its exponential form. So in order to go to its exponential form, we need to remember the formula for R. What's the formula for R? So let me just erase this. We just have to remember that if Z is equal to A plus BI, then we know that Z is equal to RE to the I times theta, where R is equal to the square root of A squared plus B squared. Alright? So since we have Z1 over Z2, let's take it off, or let's rather make some space. So make some space here. So making some space, we know that R is going to be equal to the square root of this square, the real part square, plus the imaginary part square. So it's going to be now the square root of 5 over 3 minus the root of 15 over 3 over 4, all of that square, plus the imaginary part now, look at this, imaginary part, the root of 15 over 3, plus the root of 15 over 3 square, and remember it's all over 4. Whew, a lot of work. So R is going to be equal to the square root of, now all we need to do is expand this now. When you, the first term square, that becomes 5 over 3 minus twice the product of the 2, minus twice the product of the 2. Now 5 times 15 is 75. 75, 3 times 3 is 9. Twice the product of the 2 is 2 times the square root of 75 over 9, plus the second term square, plus 15 over 3. And then when you square 4, you get 16. Plus, this now is first term square, 15 over 3, plus twice the product of the 2 is 2 root 75 over 9, plus second term square, that's 5 over 3. Square rooted all over 16. Ooh, I really hope nobody did it this way. This way is very long. Now once I do this now, what do we realize? This right here, so cancel this, and 5 over 3 plus 5 over 3 is 10 over 3, so end up with R is equal to 10 over 3 plus 15 over 3 plus 15 over 3, that is 30 over 3, and that's being divided by 16 square rooted. So this will give us R. 30 plus 10 is 40. So that's 40 over 3 divided by 16. That's R. 40 over 3 divided by 16. Now, what's 40 over 3? 40 over 3 multiplied by 1 over 16. If you're dividing by 16, you're just multiplying by 1 over 16. 8 into that goes 2 times. 8 into that goes 5 times. 5 times 1 is 5. 3 times 2 is 6. So all of this work out to be the square root of 5 over 6. So we get R now. R is the square root of 5 over 6. Alright? So once we get R is the square root of 5 over 6, now we need to find theta. Now we have to remember from the formula, theta is, depending on which quadrant the complex number is in, theta is based on this complex number, where is it in? Now, this right here is going to give us a negative x and a positive y. So z1 over z2, if we should draw a little sketch, that is going to be in the second quadrant. If it is in the second quadrant, the formula for theta is going to be pi plus tan inverse of b over a. Once the complex number is in the second quadrant, it is pi plus tan inverse b over a. So in our case right here, in our case, we can put a comma now and say theta is equal to pi plus tan inverse b. B is all of this over a. So we're going to need a little more space. So I need a little more space. So let's put a box around z1 over z2. Let's try to make some space for theta. Theta is equal to pi plus alright, so remember we have done R. Remember this is R, the square root of 5 over 6. So we can take off this part to find theta. Taking off that part, we end up with theta is equal to tan inverse of b. B is this part, the square root of 15 over 3 plus the square root of 5 over 3 over 4. All of this is divided by this part here, the square root of 5 over 3 minus the square root of 15 over 3 over 4 plus pi. You can put all of that in a calculator because remember this 4 is going to cancel this 4. So you just put this over this and then put plus pi. So we're going to do that now. So 15 over 3 square rooted plus 5 over 3 the square root of, I put the square root of bracket 5 over 3 divided by in bracket the square root of in bracket 5 over 3 close that bracket minus the square root of in bracket 15 over 3 close bracket. I get minus 3.73. So this works out to be minus 3.73. Then I just take tan inverse of that. Tan inverse of minus 3.73 and I get negative 75 degrees. Maybe you won't be able to see it. I get negative 75 degrees, but my answer is in degrees. So I get negative 75 degrees plus 180 degrees. Pi is 180. I like to do everything in degrees, then convert. Negative 75 plus 180 is 105 degrees. 105 degrees to radians is 105 over 180 times pi, which work out to be 7 over 12 pi. So therefore, see there now, we'll find r. This is r, and this is theta. Once you find r and theta, now we can conclude, therefore z1 over z2 is equal to the square root of 5 over 6 e to the 7 over 12 times pi. That's it. So we did it. And they can tell them nice. I really hope nobody did it this way, because this way is really long for 6 months. So we're going to look at method 2 now. This was method 1 if you wanted to do it the standard approach. We're going to look at it method 2 now. Alright, so method 2, just to write it back, remember z1 was given by the square root of 5 over 3 plus the square root of 5i, that's z1, and z2 was given by 2 minus 2i. I'll need to find z1 over z2. So now, another way you could do it is using De Moivre's theorem. So method 2 is using De Moivre's theorem. Yeah, De Moivre's theorem. But first thing, what we're going to do is rewrite z1 and z2 in exponential form. So for z1, right? For z1, we know that r would be equal to the square root, let's call it r1. For z1, we can say for z1, r1 is equal to 5 over 3 square rooted square plus root 5 squared. That is going to end up give us 5 over 3 plus 5 square rooted. 5 can be looked at as 15 over 3. 15 plus 5 is 20. This is just the square root of 20 over 3. So that is R1. Now clearly, Z1 is in the first quadrant. Since Z1 is in the first quadrant, we can say theta 1 is equal to tan inverse of B over A. So it's tan inverse of root 5 over root 5 over 3. You put that in your calculator. So root 5 divided by root 5 over 3. Root 5 divided by the root of 5 over 3. I get 1.73, and then I take tan inverse of 1.73. I get 60 degrees, and 60 degrees is pi by 3. So that's theta 1. After you do that now, we can rewrite now and say, therefore, Z1 is equal to R1, which is the root of 20 over 3, times e to the pi by 3 times I. That is now Z1. Now once you find Z1, you can now simplify Z2. So we can write for Z2, we do the same and find R2. R2 is now the square root of 2 squared plus negative 2 squared. That is 2 squared is 4, 2 squared is 4, 4 plus 4 is 8. This is the square root of 8. That's R2. Since R2 is the square root of 8, we can now find theta 2, and theta 2 is going to be, this is clearly in the x is 2, y is negative 2, that's in the fourth quadrant. And so theta 2 is tan inverse of b over a. Tan inverse, let me make sure, positive x, negative y, fourth quadrant, yeah. So this is now tan inverse of b over a. So it's tan inverse of negative 2 over 2. Alright, and remember the angle that we want is what it makes with the positive x-axis, this right here. Alright, angle it makes with the positive x-axis. So what we're going to end up getting now is that this works out to be tan inverse of negative 2 over 2 is the tan inverse of negative 1, that's minus pi by 4. That's what we get for theta 2, minus pi by 4. So now we can write, therefore, z2 is equal to the square root of 8 times e to the minus pi over 4i. Almost finished. Now we can say z1 over z2 is equal to this divided by this. This is where De Morgan's theorem is going to come into play now. We have the square root of 20 over 3 divided by the square root of 8. And also we have e to the pi by 3 I over e to the pi by 4 I, and this is a minus. Now, we just need to divide these now. To divide them, the square root of 20 over 3 divided by the square root of 8. You can just think of this as one big surd. So first thing, look at 20 over 3 divided by 8 is 20 over 3 times 1 over 8. And that is just 40 over 16, which is 5 over 6. Wait, let me go again. $20 over 3, oh, 24, sorry. 20 over 24, that's 5 over 6. That's 5 over 6. So this is the square root of 5 over 6. And then now we have pi by 3 minus pi by 4. So this is now e to the pi by 3 I minus pi by 4 I. Now pi by 3 minus pi by 4, that's just pi by 3 minus pi by 4. We'll bring it up here. Let's go. Pi over 3 plus pi over 4. LCM is 12. 3 pi plus 4 pi. That's 7 pi over 12. I forgot to put the minus here. Take off the minus. This is a plus here. Alright. What am I putting minus here? Yeah. Because remember, why it have to be plus here? Remember when you carry it up into the power, right? Using laws of indices, when you're dividing, you carry it up into the power, minus and minus become plus. So sorry about that right here. The minus is here, so this is a minus. But when we carry it up into the power, it becomes positive. So when we simplify this, we get the square root of 5 over 6 e to the 7 pi over 12 times I. That's it. Remember when you carry up this minus here, so it's going to become positive. Alright? So that's how this becomes positive in that numerator. That's how we do this. You could have done it method 2. Or you could have used method 1. Any way you prefer is totally fine. Nice. Using a calculator, determine the value of z1 over z2 squared. We need to work out z1 over z2 squared. Now we just found out that z1 over z2 is, remember we just found that z1 over z2 is the square root of 5 over 6 e to the 7 pi by 12 I, that's z1 over z2, so we're squaring this. If we're squaring this, it is going to be root 5 over 6 squared is 5 over 6, and so we're left back with e to the 7 pi over 12i squared. Now what does this mean? This means I have 5 over 6, this is e to the 7 pi by 12i multiplied by e to the 7 pi by 12i. When you're squaring something and multiplying it by itself. But when the bases are the same, we add the powers. So we get 5 over 6. Add the powers, this is e to the 7 pi plus 7 pi is 14 pi over 12 times I. I times I is actually, yeah, that's just I. We'll add them. When we add them, what we end up getting is 5 over 6 e to the 14 over 12 is 7 over 6 pi times I. But they want the value for this. So since they want the value for this, we're going to convert this to the polar form. By converting it to the polar form, allow you to get to the value of this quite easily. So this is now just 5 over 6 multiplied by, so remember in polar form this is r cos theta, so it is the cosine of 7 pi by 6 plus I sine 7 pi by 6. That will give us the value. So if we work this out now, 7 times 180 divided by 6, the cosine of 210 is minus root 3 over 2. So this equals 5 over 6 times minus root 3 over 2 plus, well, let me make better space, equal 5 over 6, the cos of 7 pi by 6 is minus root 3 over 2 plus I sine 7 pi by 6, so the sine of 210 is minus a half, so I can change this plus to minus a half I, and that's your answer. You can simplify it if you want. I don't wish to simplify it. You can, I won't. I leave my answer right here. 5 over 6 times minus root 3 over 2 minus a half I. You can simplify that if you want, and that's that. Alright. Question 1b, it says 1 root of a quadratic equation is given as 4 minus 7i, and it wants us to determine the quadratic equation with real coefficients with root 4 minus 7i. So first thing, if 1 root is 4 minus 7i, we have to remember that roots occur in conjugate pairs. So what this means is the other root is 4 plus 7i. So those are the two roots. So one root is 4 minus 7i, the next root is 4 plus 7i. So then now we have to remember that the equation of a quadratic is written in the form x squared minus the sum of the roots plus the product. So a quadratic equation is always in the form x squared minus the sum of roots times x, sum of the roots times x plus the product of the roots. So the quadratic equation in this case, the quadratic equation is going to be x squared minus the sum. The sum is 4 minus 7i plus 4 plus 7i times x plus the product of the roots. To multiply these two, 4 minus 7i times 4 plus 7i. When we multiply them, what we're going to get then is the quadratic equation is given by x squared, 4 plus 4 is 8, minus 7i plus 7i that gone, so that's minus 8x plus 4 minus equals 0. This is now the difference of 2 squared, so that is plus 4 squared minus 7i all squared equals 0. So the quadratic equation is given by x squared minus 8x. 4 squared is 16. 7i squared is 49i squared. So that is plus. This is 16 plus 49. And that works out to be 65. So this is minus 8x. Put back the x squared. This is a quadratic equation. So that's it. We just have to remember that a quadratic equation is written in the form x squared minus the sum of the roots times x plus the product of the roots equals 0. Once you remember that, this question is quite easy. Alright, and this question will work 4 marks. That's that right there, 4 marks for this. Nice. Alright, question 1 part C says, show that the derivative of sine inverse of cos x over 1 plus sine x with respect to x is. So to prove it, what I'm going to do is call this y. Let y be equal to sine inverse of cos x over 1 plus sine x. So that's what we're going to do. So we'll call this now. So look at this. If we call inside this bracket u, let u be equal to cos x over 1 plus sine x, right? If we call that u, then that would mean that du is, we can find the derivative of u. Let's write it right here. So du would be equal to, you start with the bottom, 1 plus sine x times the derivative of the top. Derivative of cos x is, when you differentiate cos, you get minus sine x. Plus, well, minus the top, cos x, times the derivative of the bottom, which is cos x, over the bottom square, which is 1 plus sine x all squared. Now, why did I call this u? Because if I call it u, then if I call this u, then I know that therefore y is just sine inverse of u. If y is now sine inverse of u, I know that dy by dx is going to be equal to dy by du times du dx. Because now I can apply chain rule. Dy by du. When I differentiate sine inverse of u, so to differentiate, to find dy by du, when I differentiate sine inverse of u, I get 1 over the square root of 1 minus u squared. That's the derivative of sine inverse of u, times du dx. See du dx here? Du dx is this up here, which is 1 plus sine x times minus sine x minus cos x times cos x is cos squared. So minus sine x times 1 is minus sine x. Then sine x times sine x, that's minus sine square x. Cos x times cos x is minus cos square x over 1 plus sine x all squared. That's what we have for dy dx. Now we can go ahead and simplify. Therefore, dy by dx is equal to, now look at this. This minus sine square minus cos square, that's negative 1. Minus sine square minus cos square is negative 1. Because look at this. Remember, sine square plus cos square, that's equal to 1. So if you multiply through by minus 1, that would mean minus sine square x minus cos square x is negative 1. Follow up top up here. Follow that. Minus cosine square minus cos square is negative 1. So this part here is negative 1. So dy by dx is 1 times minus sine x. So dy by dx is 1 times minus sine x. So let's write it this way. 1 over, We're just going to put in back for u now. Remember, u is cos x over 1 plus sin x. So dy by dx is 1 over the square root of 1 minus u squared. This square, if this is u, we need to square it. So it's going to be cos x over 1 plus sin x. And all of that is being squared. So we can put cos x all squared over 1 plus sin x all squared. Now this is the key step now, guys. This is this one here. Since this is 1 plus sin x right here, so we can change this 1 to 1 plus sin x over 1 plus sin x. We'll do that in the next line. Multiplied by, this is minus sin x minus 1, minus sin x minus 1 over 1 plus sin x all squared. So you see in this line right here, so minus sin x minus 1, we can factor out a minus and write it as sin x plus 1. That's beautiful. So let's factor out a minus right there. Now to simplify off this part now, as we say, we're going to change this 1 here to 1 plus sin x all squared. Why are we going to do that? If we do that, what we're going to end up with is dy by dx is equal to, multiply the two numerators across, because we want to write it as one fraction. To write all of this as one fraction, look how beautiful it's going to become. Alright, so first thing is to write as one fraction. You see this square here, so too. We can change this and raise this to the 4th power and put a square root. 4th power and square root it, because look at that. Square root 4th power, you get back your square. This allows us to write it to one fraction easier. So now what we have is this times this, which is, oh, and we don't even have to do that. My apologies, we don't even need to do that. Keep the square. I saw a shorter way. Keep the square. Let's use a different column. Right here, so sin x plus 1 over 1 plus sin x. One of them going to cancel. The sin x plus 1 will cancel the square. So this works out to just be minus 1 over 1 plus sin x. Minus 1 over 1 plus sin x. So now when we do that now, we can multiply 1 times minus 1 to get minus 1 over the square root of, rewrite this one as 1 plus sin x all square minus cos square x all over 1 plus sin x all square. That's this part right here. And remember, it is then being multiplied by 1 plus sin x. But 1 plus sin x by itself is what? 1 plus sin x, that can come in here. So now, we can put times in this denominator. Remember right here, so when you multiply the two denominators, we're multiplying 1 plus sin x. But 1 plus sin x can be written as 1 plus sin x all square. I didn't write this square root better, this part here. Alright? This 1 plus sin x here is 1 plus sin x square rooted. So see it here now. This 1 plus sin x square, cancel the 1 plus sin x square. So we're just left back with 1 plus sin x square minus cos square x. That's what we're left back with. 1 plus sin x square minus cos square x. So this works out to be minus 1 over, all you need to do now is to get what they wanted us to prove. We just need to expand. Oh no, we don't even need to expand, we got it. So there it is. We're left back with minus 1 over the square root of 1 plus sin x square minus cos square x. That's the answer. And this is where it's 6 marks. That's it. That's how we do this right here. Just a little bit of algebra, but there's nothing really to it, just a little bit of algebra. Alright? So I think what we need to remember right here is the sine x plus 1 and the 1 plus sine x squared. The sine x plus 1 cancel out the square here and left back with 1 plus sine x. But then we just need to remember that 1 plus sine x, that can be written as 1 plus sine x square rooted. That's all I'm saying. This part, 1 plus sine x, here we can rewrite it as 1 plus sine x square rooted. But then when you multiply square root times square root, you can just write it as one big square root, and instead of 1 plus sine x squared, cancel out the 1 plus sine x squared. So that's how we just left back with that part. So as long as you remember this, we're fine. Alright, part D, it says a curve is defined parametrically by x equals 3 minus 2t squared. So x is equal to 3 minus 2t squared. And then they tell us that y is equal to t cubed minus 2t. And they say determine the equation of the tangent at t equal 2. So, first thing we need to do is find dy by dx. To find dy by dx is dy by dt multiplied by dt dx. dy by dt is when we differentiate t cubed, we get 3t squared. When we differentiate 2t, we get 2, so that's minus 2. And then we divide it by dt dx. To differentiate this now, we carry down the power, that's 2. We subtract 1 from the power, that's 3 minus 2t. Now multiply it by the derivative inside the bracket, which is negative 2. So finally, dy by dx, that works out to be 3t squared minus 2 over negative 4 in bracket 3 minus 2t. This is dy by dx. Now they want the gradient at t equal 2. So we're going to say at t equal 2, we know that the gradient dy by dx is going to be equal to, plug in 2 in here, 3 times 2 squared minus 2 over 4, negative 4 times 3 minus 2 times 2. Alright? 2 squared is 4. 4 times 3 is 12. 12 minus 2 is 10. So we're getting that the gradient of the tangent is 10 over 4. 3 minus 4 is negative 1. Negative 1 times negative 4 is 4. So the gradient of the tangent is 5 over 2. So that's the gradient of the tangent, 5 over 2. Since the gradient of the tangent is 5 over 2, we can tell them, well, we also need to find now the x point and the y point at t equal 2. So at t equal 2, x is equal to, plug in 2 here, 3 minus 2 times 2. 2 times 2 is negative 4. 3 minus 4 is negative 1. Negative 1 squared is 1. At t equal 2, the y value is going to be 2 cubed is 8. 2 cubed is 8 minus, put the 2 here, 2 times 2 is 4. So y is 4. So that means that at t equal 2, the point is 1, 4. And so therefore the equation of the tangent is y minus the y point. So it's y minus 4 equal the gradient of the tangent 5 over 2 in bracket x minus the x value at the point 1. That's the answer. This is the equation of the tangent. This is 4 marks. Is 4 marks? No, I'm absolutely lying. This is 6 marks. The 6 marks to do all of this. That's that. Alright? So that takes care of question 1. I really hope everybody did well on question 1 for those who just did the Unit 2 exam. Alright, and stay tuned and we're going to have a look at the other questions. Alright,